Okay, so now we're going to take a look at what do we do if we've got some data and we're trying to use that data to calculate the formula for a hydrate. How many water molecules are attached to each ionic compound? I gave you guys a worksheet. You need to do the odd ones. I'm going to go ahead and do number 8. So if you want to see how this reads, it's right there. So basically you have some students. They had a 2.24 gram sample of calcium nitrate. They heated it and it lost 0.54 grams of water. And then they used those numbers right there to try to calculate what the formula for this calcium nitrate something hydrate was. All right, so let's write those numbers down. So we've got 2.24 grams calcium nitrate. So this is kind of why we got to know our formulas. Dot something or other H2O. So it's got some waters attached to it. We don't really know how many. Well, in the data it says 0.54 grams of water is given off. So that's how many grams, the amount of mass that you lose when you heat this stuff up, that's how many grams of water we actually have. Now, so how much calcium nitrate do we have with the waters? Well, now I should have, if I did this right, just calcium nitrate left over, so I just subtract. And that should be how many grams of calcium nitrate that there are. Now, what I'm trying to find out is how many water molecules is attached to each one of these formula units of calcium nitrate. So the grams doesn't tell us how many, but we now know, you've done enough of this in chemistry, anytime you've got grams of something, if I just divide by its molar mass, divide by its molar mass, then we can figure out how many things we're dealing with. So we're going to convert to moles. You should be seeing this by now. When we give you grams of substances, a lot of times we're going to convert to moles. So we'll take the grams of water that we know we had, and then if you take grams divided by molar mass, that should give us how many moles of water we actually have. And the number I got is about 0.02998 moles of H2O. So about 0.03 moles of H2O. Now, how many calcium nitrates do we have? So hopefully I figured out the molar mass of calcium nitrate properly. I got 164. Don't forget, you've got two nitrates attached to this. This is why it's really important in your calculations. If you don't get your formulas right, you're going to have a hard time. And that gave me .01037 moles of calcium nitrate. So if you're good with numbers, you can look, this is about 0.01, that's about 0.03. You're going to have some error in these things. So it looks like I've got 3 waters, or 3 times as many water as I do calcium nitrate. So what does that mean? Well, we designate this, because it's not a typical type of bond or strong attractive force, you put a dot right there and then say how many waters is attached to each calcium nitrate. And then you can just use the prefixes that we'd normally use that's reserved for covalent bonding. And then we can go ahead and say this would be calcium nitrate trihydrate, meaning there's 3 waters attached to each thing. Now there's a technique that you can use, and this is, we're working with any kind of empirical formula. This is really an empirical formula, but instead of individual atoms of this, it's like how many of these do you have per ionic compound? And an empirical formula, you're dealing with how many of each atom do you have in the molecular compound. So if I take a look at this, what I can do is I take whatever I have more of, so that's my moles of calcium nitrate, divide this by whatever, and you can do this for a whole bunch of things. So you take the least number of moles of anything you have and divide everything by that. And this gave us about 2.891. That's not great data, but for a high school class that wouldn't be terrible. So what does that mean? You've got about 3 times as many waters as you do calcium nitrates. So that's how I came up with the 3-to-1 ratio. That's just something that makes the numbers show up a little bit easier, and you can use it for any empirical formula problem. So take whichever thing you have the least moles of in terms of atoms, or in this case molecules, divide all of your moles by that, and then sometimes you'll see a lot better ratio of how those things comparison to each other. Now sometimes you can just look at the numbers, and if you happen to be good at seeing ratios, then you can do it that way. So this is how you do the worksheet. Now don't be thrown off. I'm not going to explain every single thing in there. There's odd numbers in there. So what if they give you, say, percent by weight? Well, just treat it if it's a 100-gram sample, and then move your decimal a couple places, and you can solve the same thing. So you've got to get used to not all the data is going to be presented the same way every time. And so instead of water that left, maybe they'll tell you just how much of the dry thing left over. So a lot of stuff, when you get into more advanced chemistry and physics, is reading comprehension. Can you tell what the question's asking, and then can you tell how the numbers help you get there? So you got to really make sure you're focusing in and trying to break down the question. They're not going to look identical every single time. So we'll see you tomorrow. Try to do those odd problems. If you don't have all of them due, they're not going to be due till before you do the lab, which will be Wednesday for first hour and Thursday for second hour. Thanks.